In our last video, we saw 7 properties of integrable functions. In this problem, or in this video, we're asked to solve these 3 problems given this little bit of information about 2 functions called f and g. And what I know about f and g is apparently they are both integrable. F is integrable from 1 to 5, and its definite integral from 1 to 5 is 8. Its definite integral from 3 to 5 is 5. And then g of x is definite integral from 3 to 5 is 3. So all I know about g is that it's integrable from 3 to 5. And then I'm asked to solve these 3 puzzles based on that information. And I know we haven't done any of these together. We've just seen those properties, but I still think I'd like you to pause the video here and just see if you can come up with answers for these. When I show my work, I'm going to go through and show all of the steps I can where I use those properties. But for now, just go through and see if you can reason your way through what these answers should be. Okay, let's go through them one by one. In problem number 1, I have the definite integral from 5 to 1 of f of x. The order of integration property tells me that this would be the opposite of the integral from 1 to 5 of f of x dx. Well, I know the integral from 1 to 5 of f of x is 8. So here in number 1, my answer must be minus 8. Number 2, I'm given the difference of 2 functions in my integrand multiplied by different things. So what I'm going to choose to do first is split my definite integral up using the difference rule. Okay, when I split my definite integral up, I notice that there's a dx on both of my definite integrals. A definite integral always requires a differential operator. It has physical meaning here. It's taking the place of the delta x from my Riemann sum. It's also expressing the integrand in a differential form, which is important. And now I can use the constant multiple rule to factor out the constants. Going back to the original given information, I now know that the integral from 3 to 5 of f of x was 5, and the integral from 3 to 5 of g of x was 3. I see those 2 integrals here, so this is 3 times 5 minus 4 times 3. 15 minus 12 is 3. So this definite integral in number 2 is equal to 3. All right, just one more problem. So I need to find information out about the integral from 1 to 3 of f of x dx, and I'm given information about the integral from 1 to 5 and the integral from 3 to 5. And I have a feeling a lot of you all thought about it in terms of maybe a picture that looked something like this, where the total area shaded all the way to 5 would be 8. But that this little bit of area that's shaded between 3 and 5 would be equal to 5. And so I haven't done a good job of doing this to scale because that would leave 3 square units of area right there. And that would be a correct way to reason through this problem. You could also think about it in terms of additivity. The integral from 1 to 3 of f of x dx is equal to the integral from 1 to 5 of f of x dx plus the integral from 5 to 3. I can then use order of integration to change the bounds the way I'd usually like to think about them here. I know that this first integral has value 8. And the second one has value 5. And 8 minus 5 is 3. Using additivity and order of integration there does establish that we're really subtracting a smaller area from a larger area.